Hello, Pre-Calc. We're going to do some quick introductory notes for section 2.5, complex zeros in the fundamental theorem of algebra. So the big thing in this section is the fundamental theorem of algebra, specifically if f of x is a polynomial of degree n, f of x will have at least one zero in the complex number system. Complex number system. Now, you might be thinking, does that mean it is specifically an imaginary number? Not necessarily. Remember, a complex number has the real and imaginary piece, but if we think about everyone's favorite example of x squared, well, this 0, x equals 0, it doesn't have an imaginary piece, or we could write it as plus 0i, which doesn't necessarily make it any better. But that is our first theorem, and the second is the linear factorization theorem, which I'm not going to write out in its fancy form. All I'm going to say is if it is an nth degree polynomial, we can expect n factors. And some might be imaginary. Some might be real, some might be imaginary. Oops. I kind of mentioned this the other day in class when we looked at the intercepts of the y equals x squared, y equals x squared plus 1, and y equals x squared minus 1. Imaginary. All right, so let's look at this in action. We've got 3 examples, and they're going to be pretty quick because these are very simple. Find the zeros of each of the following. For this first function, I notice that my degree is 1, right? X plus 7, this is just a first degree. If I set x plus 7 equal to 0, x equals negative 7 is my 0 here. I have a first degree. I found 1 0. It is a real 0. That's it. Our second one, f of x is equal to x squared minus 8x plus 16. I notice that our degree is 2, so I should expect to see 2 zeros. If I look here, I'm going to try and factor it. Things that multiply together to get 16, 16 and 1, 4 and 4, but they have to add up to negative 8. That would be x minus 4, x minus 4, which we could write as x minus 4 quantity squared. My 0 then is 4, and it has a multiplicity of 2, right? It is repeated. So we could also say it's a repeated 0. So even though I don't have 2 different zeros, it is repeated. There are 2 copies of this 0, so we got that. And then last but not least, we have x cubed plus 25x. First thing I'm going to do is note that our degree is 3, so I should expect to see 3. I can also factor out an x. I'm left with x squared plus 25. If I factor this, well, actually I can't really factor it, but I can set each of my pieces equal to 0 and then solve. X squared plus 25 equals 0. This is my first 0. Over here we get x squared is equal to negative 25. X is equal to plus or minus square root of negative 25, which we wouldn't write like that. We would say positive or negative 5i. Here are my other 2 zeros. So 1, 2, 3 makes for a total of 3. Then the last thing for the notes that I want to give you today is the statement that complex zeros occur in conjugate pairs. What does this mean? It means if I know that x equals 3 minus 2i is a factor, if I know this guy, is a factor, well, its conjugate pair must also be a factor. So then I would know x equals 3 plus 2i is also a factor. Those are the notes I want you to take ahead of time. Everything else we will do in class. I hope you have a lovely day.